All right, so what we're really going to be doing is doing what they call hypothesis testing to answer the question if this is true or false. It says a manufacturer claims that the mean lifetime of its light bulbs is 46 months. The standard deviation of this lifetime is 7 months. 50 bulbs are randomly selected, and their mean lifetime is found to be 49 months. Can we conclude that at a 0.05 level of significance, that the mean lifetime of the light bulbs made by this manufacturer differs from 46 months? It says perform a two-tailed test. You do a two-tailed test when it differs, because you weren't here last time, but we had that little curve, and if it differs, I could be at this end or this end. So we're saying that the mean does not equal 46 months because it differs, right? So again, they're going to have you do the null and the alternate hypothesis. This is a does not equal, so that's your alternate hypothesis. The mean does not equal 46. My null always has the equal in it. So here my mean does equal 46. And I'm trying to answer the question, does it or does it not? So, ask you what type of test statistics you have. If I know the population standard deviation, then we do the z-test. We had a z-test, we had a t-test, and we had the chi-squared test. So, on these ones, we're doing the z-test because we know the population standard deviation. We are then going to find the value of our test statistic, which is our critical value, which we did on homework 7, and we used the formula that looked like this. Z equaled the sample mean minus the population mean over the standard deviation divided by n. So, our sample mean is the 49 months that it was found to be when I did my 50 randomly selected. 49. I'm going to do this population mean, which is the given mean. We know that it was 46 months, or that's what the claim was, that it was 46 months. Standard deviation is 7 months, n we sampled 50. And how come I wrote an n? 50. And so we're going to find the value of that statistic round to at least 3 decimal places. That you could either put in the Alice calculator, or if you just want to use your regular calculator, either way. What do you get when you put that in the calculator? I don't think that's what it was supposed to be. Let's try it again. Okay. 49. Oh, that's my fault. I messed up. I forgot something on here. That's supposed to have a square root over the top. How about I put a square root over the top? That'll make a big difference there. I have it written down. I just didn't write it on when I copied it off my paper. So there's my real formula. Now let's put it in with the square root over the top. This is homework 16. 3.030, right? Because it says to 3 decimal places. That means on my little curve that this is at 3.030, this is at negative 3.030. Now the next part wants us to find the p-value. When I'm finding the p-value, I'm finding the values in each of these 2 places here. So this is where we have to use the LX calculator. The LX calculator does the less than or equal to. So we're going to do P of Z is less than or equal to the negative 3.030 plus the P of Z is less than or equal to the 3.030. Since we have the 2 different ends and I can only do less than to find the middle is what we're actually finding. We're going to find the value of the first part, then we're going to subtract the value of everything less than the 3.030 to get the middle part. And this one says to round to 3 decimal places also. What did you come up with?
0.
Oh, you did them separately?
Yeah.
Okay. You got what?
0.001.
001, and on the second one?
0.998.
0.998.
Oh, it's supposed to be 9 because it was 7.
Oh. Ignore me because I messed up again. I'm doing all of that. I got to do 1 minus that. P of Z. I should get the same number. That's what I should get. This was this. P of Z, 1 minus that. If this is 0.001, then this side should also be 0.001. That's what I'm trying to say. If I take that in right, because this was all of this less than, I'd have to do 1 minus this amount. You got that 0.998 or something like that. But if this side comes out to 0.001, this side should also be the exact same thing. So my p-value, if I add those 2 things together, which is the next thing down that we can't see, is 0.002. You'll mark it down on yours. If p is less than the significant value, which in this case is 0.05, we're going to reject the null. If p is greater than the 0.05, then we are going to accept the null. In this case, this is going to be way less, right? So I'm going to reject my null, which means if I don't accept this, I'm going to accept the other one. The mean is not equal to 46 then, right? So it says, can we conclude that the mean lifetime of light bulbs or made differs from 46? Yes, we can, because we have to accept the alternate hypothesis. We're rejecting the null. So yes, it does differ. Now for fun, if you do your technology activity, I'm going to have you grab that one. You can do your hypothesis test on here. What I'm going to do is I am going to hit the stat button, and then I'm going to cursor over to the tests. And you'll notice that number 1 is the z-test, which is what we're doing. So hit stat, then cursor over to tests. And on the z-test you have an input. You can either input the data by putting in all your values into list 1 like we've done before, or you can do the stats. We're going to go to the stats because we know our stats. Hit enter on the stats. So the mean value here was 46. We're going to put 46 for the first one. Our standard deviation was 7. The sample mean was the 49. The number 50 is how many light bulbs we tested. Whoops, I got to do 50. 50. We did differ, so we did does not equal. So you'll notice you have choices of does not equal, is less than or greater than. We want to do the does not equal, so highlight that and enter. So if we go ahead and go cursor over to the draw one, if my graph shows up, it should look something sort of like what I have drawn. I don't see much shading because I didn't do much shading. But notice underneath there, it says z equals 3.035 and p is 0.0024. There might be some slight rounding errors because of where they carried their numbers off to, but you can double check those numbers to make sure you did your calculations right. Okay? Oh. Why is it snapping me again? The computer just doesn't want to cooperate with me today. All right, number 8 then. See how much of it I can get on here. See if I shrink my screen a bit. There. Maybe we can see it all then. Okay, number 8 then. Number 8 says the breaking strengths of cables produced by a certain manufacturer have a mean of 1,950 pounds and a standard deviation of 55 pounds. It is claimed that an improvement in the manufacturing process has increased the mean breaking strength. To evaluate this claim, 20 newly manufactured cables are randomly chosen and tested, and their mean breaking strength is found to be 1,967 pounds. Assume the population is normally distributed. Can we support that at a 0.01 level of significance, the claim that the mean breaking strength has increased? So if it is increased, we're going to say that the mean is greater, right? The mean is greater than the given mean of 1,950 pounds. So again, the null always has to have an equal sign in it. That doesn't have the equal sign, so that's my alternate hypothesis. The mean is greater than 1,950. My null then is that the mean would be less than or equal to the 1,950. Now notice this time it says perform a one-tailed test instead of a two-tailed test. If it's a one-tailed test, you're either going greater or less. In this case, we're figuring out greater than, so we're finding that little section over there to the right. Again, it's always going to ask you the type of test statistic you're finding. Since we know the standard deviation, we know we're doing the z-test. Our standard deviation is known. So again, we're going to find the value of the test statistic. This time I'll write the formula down right. I'm going to take my sample mean minus the given mean over the standard deviation divided by the square root of n. So my sample mean is which one of those numbers? They give you two different means. One's the given mean and one is your sample mean.
1967.
The 1967, right? That's the one when they did their test. That's what they got for their answer. 1967. We're going to subtract the given mean, or what they think the mean is supposed to be, of 1,950. Divided by the standard deviation, which is 55, over the square root of how many were in our survey? Looks like 20. 20 cables were tested. So if I calculate that out, either that one you can either do on your regular calculator or on the Alex calculator. Yep, 1.382 is going to be the value of our test statistic. Now this time, notice they're not having you find the p-value, you're finding the critical value. So this is when you did the z sub on your calculator. We're going to do z sub 0.01 to find where that critical value is. So on the Alex calculator, if you do z of 0.01, what do you come up with? Practice punching these in. What do you get when you do z sub 0.01? 2.326. Okay. So what this is saying, if I'm interpreting that, this is where my null is, because that was the less than or equal to section. This is where my alternate is, because that's the greater than section. My critical value is the value 2.326. This is my test value. Does the test value fall in the null section or the alternate section? Well, since it's less than this value, it's going to fall in this section. 1.382 is going to be over here on that side, right? Because it's smaller than my 2.326. So, since this is where my test is, I have to accept whatever my null statement was. So I have to accept that the mean is less than or equal to 1950. The question says, can we support the claim that the mean has increased? No, we can't accept that. We have to accept that it's less than or equal to, so it didn't increase. So I have to say no, I can't accept that statement. So when they give you the critical value, you mark where your test value is, depending on if it's a less than or a greater than, and that tells you which one of these two things you should accept. I have to accept the null.
How do you type it in?
So here you would do the z sub, and then you're using 0.01. And equal. Yeah, okay, that's the 2.326. Yep. So, yep. So when they ask you for the critical value, that's the easier one to do because you just have to do that. Now again, if we take the graphing calculator just to check our answers, we're going to do stat, we're going to cursor over to tests, and we're going to do the stats because we know the statistics on this one. It's already probably highlighted because we did stats on the previous one. Our given mean was the 1950, right? 1950. Our standard deviation was the 55. Our sample mean was the 1967. And our N was 20. This time we did the mean is greater than 1950. So we would cursor over to the greater than. And again, if I go down to the draw and hit equals, it's going to draw. There we can see some shading because our section wasn't so small. But it tells us the test value was 1.3823. Our p-value, which it didn't ask on this one.
Oh, did I do one wrong?
Oh, yeah, it looks that way. Let's look at that again. So hit stat for me and go to test. Number 1 is your z-test. Yep, there, 1950. Oh, the standard deviation was 55. Oh, this is supposed to be 20 instead of 50. This problem, we only had 20 in our sample.
So everything.
And then we want to do the greater than. And then go to draw. There. So it is showing us that here was the greater than 2.326 was this section here. Since our test value was 1.382, we had to be the other section, which is the null hypothesis. So you can do at least a little bit of double checking with your numbers. All right. Thing is gonna drive me crazy. Let's do the next one there, number 9. So number 9 says a leasing firm claims that a mean number of miles driven annually in its leased cars is less than 13,360 miles. A random sample of 70 cars leased from this firm has a mean of 13,254 annual miles driven. It is known the population standard deviation of the number of miles driven in cars from this firm is 1,080 miles. Is there support for the firm's claim at a 0.1 significance level? So their claim is that the mean is less than 13,360. Right? That's their claim. So, since that doesn't have an equal to, that's the alternate. The null always has the equal to. So the mean is less than 1,360. That means my null would be that the mean is greater than or equal to the 1,360. The null always has the equal to symbol in it. Type of test statistics, since we know the standard deviation, we know we're doing the z-test. We knew that because all of these are the z-tests. So, first of all, we're going to find the value of our test statistics. So, my sample mean minus my given mean over my standard deviation and the square root of n. So my sample mean is what number?
I don't have this homework. It's not in my thing.
In chapter 8?
Yep. I don't have any chapter 8.
Huh, strange. You guys had chapter 8?
Remember, I was missing like 3 other ones too.
Here, we'll print that. It'll probably take a minute. So. We said here the mean was greater than or equal to or 1,360. The mean is less than 1,360 here. We're doing the z-test. And now we're finding the value of our test statistic by taking the sample mean minus the given mean over the standard deviation and the square root of n. So on this one it says the sample mean is what number? So in my sample, what is the mean? That is the number, that's the n, that's the number that we sampled. Keep reading that sentence.
Is it the 13,200?
Ah, there it is. The sample has a mean of 13,254, right? We're going to subtract what the given mean, or at least what the claim of the mean is. The mean is 1,360 there. My standard deviation in this problem is 1,080 over the square root of n. N is how many things they sampled, which was 70. That is what I'm going to put into the calculator in order to find the value of my test statistic. That's printing out back there if you want to grab that. You punch that into the calculator. What do you come up with?
Which one is this, 5?
This is
Number
number 9.
Can you do that calculator?
Oh, certainly, yes. Whichever calculator you want to use for that one. It could be the health calculator. You could just use a regular one if you wanted to. It's probably easier on the Alex calculator to get it punched in the right way. To 3 decimal places is how far we want our answer.
Is that a B or 1 3?
It's a 1-3.
13360.
Oh yeah, 13360. That's our claim. It's less than that number. What are we getting for the value of our test statistic if you get that punched in?
How do I do it on the calculator? On this calculator? Is this what you want us
On
to
the
do
regular calculator, you would have to put in the top in parentheses, or you'd have to figure that number out right away. 1,300 or 13,000. 13,254.
Oh,
That's the 13,254 minus the 13,360. It equals, get that top number, enter. Then you're going to divide that by 1,080 divided by the square root of 70. Square root, you have to do second function.
Oh,
So back that up and do second, and see how the square root is in blue? So second function, square root of, whoops, it's still up in the exponent. Oh, let's see if we can get that out of there. Oh, there's no delete. There, now second function, square root of 70 equals. Is that the right number? That is not the right number. What does that not like? Do I have to put parentheses around the bottom? Let's try it this way. Put in your negative 106. Negative 106. Divided by, and then put parentheses, 1,080 divided by, whoops, nope, in the same set of parentheses, because that's all together in the bottom,
okay.
square root of 70. And close your parenthesis, whoops, gotta close our parenthesis on the other side, so cursor over, delete that, delete again. Okay, now cursor so you're outside the square root, and then close the parenthesis. Now let's hit equal and see if that works. That's the number we should be getting. So yeah, we have to put parentheses
Okay.
around that bottom part so it knows that all this is together.
Okay.
So we got negative 0.821. So on, the other two disappeared on me. On this one, we're doing a left-tailed test. Since this is a less than, we're checking this section right here, and that's why this ended up being a negative value, negative 0.821. Now, in the next part, you have to use the Alex calculator. So go ahead and log on, because those two disappeared on me anyway.
Yeah, the thing is this computer won't let me log on. I was trying to log in earlier. It was not letting me do it.
That's your rights to 90. Oops, that's okay. Other user. Somebody was just on earlier, so I'm just gonna see what kind of message we're getting here.
'Cause it rejected me like 4 times.
We must have just typed something wrong, because now it says it's preparing your desktop.
Okay.
This is writing in weird spots. So you got logged in there, still working on it.
I need a password.
Oh, that's right. Click in there for me. Go ahead and hit start. Oops. Switch back to the other password. Now hit start. Yes, it did. All right. So, on problem number 7, which you missed out on, we had this. If my p-value is less than the test value, we would reject the null and accept H1. If the p-value is greater than, we accept the null and reject H1. We have to first find our p-value. So this is what we were doing last week, was finding the p-value. So on
Reject.
reject the H sub 0, which is the null,
Okay.
and accept the H1. If we reject this one, we're going to accept this one.
Okay.
If it's a greater than, it's going to be the other way around. We're going to accept the null, that would be true, and reject the H sub 1. My pen didn't want to write exactly where I thought it should. So we have to find the p-value. So to find the p-value, we're going to do p of z is less than whatever the number is we got here, which we got negative 0.821. So in the Alex calculator, you're going to just punch that in. Since it's a left-tailed test and our z goes less, we're just going to put in that. And we're going to find that to 3 decimal places, it says.
Okay, which one do I use?
The P of Z one.
This one?
P of Z, this first one. Yep, P of Z, and then you're going to put in that answer we got on the previous part. Negative 0.821.
Just equals?
Yep,
Is it 0.20? How many places? 3?
3.
6.
Okay. So what we're going to compare that to is the significant level that it says up here. So if I have 0.206 and I'm comparing it to 0.1, is this greater than or less than that?
Greater.
It's greater. Since that's a greater, we are going to do this one down here.
Okay.
We're going to accept the null. That means that the mean is greater than or equal to this number.
Okay.
The question says, can we support the claim that the miles driven annually is less? No, we're saying that it's greater than, right? So, can we accept that claim? No. We can't say it's less because we ended up it was greater than. Then we said just to double check our calculations, we can use our calculator, right? And practice using that. So we hit the stat button. We cursored over to tests. And we're doing number 1 for the z-test because that's the type of test we're doing, right? And we're using the stats. So stats should be highlighted. If it's not, cursor over to stats and hit enter. If you've already been using stats, it's already highlighted. Then we have to put our numbers in the correct places. So, the X bar one was the 13,254. The mean one is the 13,360, right? So the top one is the 13,360. Our standard deviation is this number here, which is the 1,080. Our X bar number is the 13,254. And our N is the 70. You don't do the square root, you just put the 70. That's how many things we tested. On this one, when we're doing our test, we're doing the less than, right? So we highlight the less than, then we're going to cursor down to where it says draw. and we're going to draw. And it's going to draw something that sort of looks like what we drew up here, but more importantly underneath, notice it gives you the z-test value, which is the negative 0.8212 because they carried it out a little farther than us, and the p-value 0.2058. Whoops. Okay. So, 13,250. Whoops, no, the top number, the mean number, up on the top, cursor that up. Why doesn't that want to move? It's stuck, huh? Let's just hit clear. Now won't move? Yeah. We'll put a number in there. It just doesn't like to be blank. So, the mean number should be the 13,360. The X bar number is the 13,254, right? The standard deviation is the 1,080. And then the N number is the 70. On this one, we are doing less than. So I'm going to enter on that. Yours is going to draw orange. We're going to go over to draw. And there it is drawing it. Since we were checking a less than, it highlighted the left side. There's the z-test value. There's the p-test value. So that number should match here. This number should match here. Other than they rounded it off to different spots.
Okay.
We still need to know how to interpret the test, but at least we can double check our calculation. I don't know where those two got lost at. All right.